Hey Savvy Devs, it's Savvy Nick here, and today we'll continue programming our Simple List project. In this episode, we'll do a little bit of cleanup and introduce a new C++ topic, which is very important, called classes. Now this will also bring the topic up of objects, which are the building blocks for object-oriented programming. So let's go ahead and jump in and start the cleanup process here. What I first want to do before going ahead and creating a class is let me change something up in main that I found wrong last time. So down here we had a problem, I believe, with the list index. And let's go ahead and run the program real quick just to make sure that I'm right. We'll go ahead and go to the terminal, create a new one, and we'll run our make command here. It says nothing to be done for all. We're going to make clean first, so we clean everything up and run make again. And as you see, we have this warning here that our comparisons are two different things. One's a long unsigned integer, int, and then another one is just an int. So one is signed and the other one is unsigned, meaning one can exist in a negative notation and the other one cannot. So in order to make them the same, what we can do here is we can typecast. So if we just type in parenthesis int parenthesis close parenthesis, then what this will effectively do is typecast, change the type of this data type, if possible, to an integer. So that should get rid of at least one of the warnings. I believe we have another one that we did up here, and we do under delete item. We should also do it here. So if we just do int in parentheses, this will typecast this list size, whatever it returns, into an integer. Now this can't be done with everything because you might lose the proper value if you try typecasting from one variable to another variable and the data type sizes just don't match up. So think of it as not enough bits can be stored in from one data type to another. You would get some of the bits truncated, therefore giving you the incorrect value. So be careful when you're typecasting, but this should be an easy way to get around the problem. So let's go ahead and save that. And we can rebuild here. Let's just do make again. And you can see this time it did detect that we made some changes. We added in that int typecast. And now we were successfully compiled without any warnings. So that's great. That's exactly what I wanted. So now that we've taken care of that, let's go ahead and move some code around. The first thing I want to do is I want to go into our make file. This is what actually compiles our code. And we have this source directory parameter. Let's go ahead and change this back to src, since we're not going to be working in the main simple list directory anymore. So if we just type in src and save this, let's go ahead and try compiling once more, and we should see it fail now because the compiler will not know where your current main CPP file exists. So let's go ahead and do that real quick. Let's run make, nothing to be done for all. Yeah, that's because it's already made and we changed nothing. So make here, it says no input files. So it couldn't find main.cpp. Well, don't worry, we're just going to be moving it around a little bit in order to structure our program just a little better here and then introduce a class. And if you're new and stopping by to watch an episode today, please take a moment to subscribe below and hit the notification bell for upcoming programming tutorials and other videos on the channel. We'll go ahead and exit out of the make file after we've saved it. And let's go ahead and just move this main CPP file up to the source directory. And it's going to ask you, are you sure you want to move the main CPP file to the source directory? And I'm just going to hit move because I am certain. So now we have the main project file or directory. And then if you expand that, you have a few more directories underneath it. One's an object directory. So this is where things will be compiled, a source directory where we actually write our code into. So in the source directory, we have an includes folder or directory and a main CPP file. So let's go ahead and make sure that we can build our project still. We'll just do make again. And there you go. Now it recognized it. And we have simple list generated. So let's make sure we can run simple list. So here we go. We just type in simple list. It says username not supplied, exiting the program just like we would expect. Great. And now since we went ahead and verified everything still works and can compile correctly after moving some stuff around, we're going to go ahead and exit out of the terminal. And let's go ahead and introduce a new file to our program. And where we're going to introduce this file is in the includes folder. So make sure to right click on the includes folder and hit new file. We're going to go ahead and call this list.h. So .h stands for a type of file extension known as a header file. And all that header files are just a place to really keep prototypes and definitions and some variables. That way you can kind of distinguish between your source code and definitions that you have for your source code. This is an older idea, and that's actually why it has this little c instead of a C++, because it was initially introduced in C instead of C++. And we're going to go ahead and use this to go ahead and define our class. So what is a class? A class is really a building block to object-oriented programming because it's a data type that's user-defined. And in this data type, you can go ahead and specify whatever types of variables and functions that you want to exist in them. So classes are really designed to help you organize your code better and make things look much cleaner, hopefully minimizing the time it takes someone else to look at your code and learn about it. You can technically get away without doing any type of object-oriented programming or introducing classes, but it would be very hard to follow your code, and especially when the code base gets very large. So in our list.h, how do we define a class? Well, we simply do it by typing in class and then putting braces. Now inside those braces, we get to define something called members. And all the members are functions and variables, just like we talked about before, but specifically inside of a class. So don't let members trip you up. It's just a function or variable like we've been using. So up here, after class, we want to define our class name. So we just type in list. I'm going to call this class a list. And inside of list, there are going to be our member functions and our member variables. So let's go ahead and define a few, but technically all of these already exist in our main CPP file. We just want to move them over. But before we do, there's three things we want to talk about, and these are called access specifiers. So we have the private one, the protected one, and the public one. So you shouldn't get too tripped up about what these are, and I'm missing a semicolon here at the bottom. So all that private means is it's an access specifier that says anything in this area underneath private will only belong to this class. So only the class itself can see anything that's defined in this space between private and protected. And it really doesn't matter what order you define these in, as long as you keep your statements in between the two. So here, anything defined in protected will mean that only the class itself, list, or anything that inherits the list class can access member functions and variables of this class. And then public, that means any classes or outside source files can access the members inside this class. So basically, if you want anything to access member variables and functions, you put it in public. If you don't want anything to access it, go ahead, put it in private. And if you want some things that are related to list to access them, you'll put them in protected, simply put. So we're just going to use public for now. I'm going to keep these blank, so I'm just going to put them together here. And then in the public section, let's go ahead back to main and copy a few things. The first things I want to copy are going to be the function prototypes that I defined before. So I'm going to go ahead and just do copy, go back over to list, paste it in here, just because I want to clean things up, move them out of there. Also, I know in the last video I wanted to go ahead and remove this argument from the print menu. We don't need to go ahead and pass in name. We'll go ahead and make that also a member variable in this class. So we're going to move that there, get rid of that. We'll also go ahead and move these two in. So let's go ahead, copy that, paste this as well into public. We'll make this as simple of a class as we can. And right now the IDE is complaining a little bit. It doesn't know what vector or string is, so we're going to have to include two things here, the IO stream functions of the standard library, and again include the vector functions of the standard library, just like we did in main up here. And we can also do the using namespace std, so we'll copy that over as well, right below. And then that means we can get rid of all of this. And you see how we're slowly cleaning things up here, although it looks a little messy right now because we've got red all over the place. Now let's just make sure that this all looks good, and I think it does. So I want to create one more new file here. Let's go ahead and in the source directory, create a new file. And this one's going to be called list.cpp. Go ahead and save that. And once we have our list.cpp file made in the source directory, we're going to go ahead and actually copy a few more things out of main. So really, all I want in main is my main function. I want to make it look as clean as possible. And I want to put all the relevant functions to my list class and or object into the list.cpp file. So all these functions here that we created before, called print menu, let's see what else, add item, delete item, and print list, we should move those. Let's go ahead, since they're part of our list, move them to list. So we'll just copy all of those functions. And once we got those copied, we can go ahead and delete them out. So only main is left here in our main CPP file, and move them over to the list CPP file. So go ahead, paste that in, and I bet you we get a little bit of complaining here that some stuff is missing. Yep, so it can't resolve cout, it can't resolve string, can't resolve a bunch of things here. But that's okay, because the IDE currently doesn't know what in the world a string is and all that fun stuff. So what we can actually do is include our header file, because our header file already has IOStream and vector and what namespace we're using, the standard namespace, and that will help resolve all of these things that are currently in red. So let's just do this, include, and we'll do quotes here. And now, where is list.h? Well, list.h in relation to the CPP file is in our include folder or directory. So let's go ahead and just do include. See, it's getting resolved here. It realizes that it's a folder. And then we'll do the backslash. And now it populates the list.h. So go ahead, put list.h in there. If we save this, you can see that a lot of the red here goes away, which is great. So one thing that we did earlier is we went ahead and removed an argument from print menu, at least in the prototype. So we actually have to do that with every single place we pass in an argument and where we'd actually define the function. So here, print menu string name will not match what's declared here. So let's go ahead and fix that. We'll remove this and save it. And then I'm just going to keep looking here for other places that might show up. Here. So we're passing in a name. Can't do that anymore. And again, we're passing in a name. We can't do that anymore. And once more here, we're passing in a name and we can't do that anymore. So once we got that fixed, should be good. Let's go ahead and go back here and talk about a few more things. There's also some functions that always come standard when you create a class, and those are the constructor and destructor. So these are special methods which are reserved whenever you create a class and will always follow the class name. So what do I mean by that? I mean, there's a function that's already predefined that is called list, and then you can go ahead and overwrite that function by creating one like this. And then there's another one with a tilde, just like this. So why are these two special? So this is actually a constructor, spell that right, and this is a destructor. A constructor gets executed whenever the object gets created. So whenever we define our object in our code and it gets called to go ahead and create that object, this constructor will always be called and things inside of here will be executed right away. So this is just really good for initializing values in your class if you need to do so. And then the destructor will get called whenever terminating the program in some fashion, let's say deleting an object, which we'll talk about at some other point, or going out of scope of where this class was created as an object. It's just some little tidbits to know about classes. We can keep them here with nothing in them. This is just notes right now. So if you ever need to make a note, you can just do 2 backslashes and then followed by your note. This will only be good for 1 line. And if you're in this far, go ahead and take a moment to hit the like button. It really does help me out. Let's go ahead and save this. And then let's go back to our list CPP. Well, right now we've included the list.h file. Everything looks okay, but there's one obvious thing that I see that's wrong. So right now, this print menu function, these are just functions that look like we've created, but they really don't know what they belong to, because we also have the same exact functions named in our class. Well, we need to tell the source file that we want these to belong to the class. And how do we do that? Well, that's really simple. We just go list : and now list can correlate itself and say that, okay, I'm a class, I'm called list, I have these member functions, and now these member functions are going to be defined here. So much like we did prototypes before, here are basically our prototypes that exist to list, and here we're just correlating those two together by doing this list : and telling it, hey, I'm defined right here. So let's go ahead and do that to every function. We'll add it in here. We'll do list : and that's why the IDE was complaining there for a moment. And as you can see here, it doesn't know where it's going to get list from. Well, that's because it doesn't know it's part of the list class. So let's go ahead and do that there as well as here. And now we're in a really good place to go ahead and hit save. And I think we just have a little bit more cleanup to do, and I think we'll be done here. And we can look through our 3 files that we have now. And let's go real fast to main and check out what problems we have in there. Well, the first problem I see is it doesn't know what name is. And I remember that print menu did get name taken out of it, so I'm going to take it out of here as far as an argument goes. And it doesn't know what cout is anymore. Well, yeah, we removed the included functions from the standard library, so we got to include them again, or we can just go ahead and include list.h. And we want to include list.h because we want to include our new data type or class called list. So let's go ahead and do that. We'll just do that by doing include again. And we already know where this one's at, so it's in the include folder as list.h. And it should resolve most of these issues now. Wait a second, I messed that up. We don't want these angle brackets, we want quotes here. And now that should fix that. And you can see now it resolves string and the cout functions. So let's go ahead and change this up because it doesn't know what a name is. Well, what happened to name? Well, we moved it into a class. So this class here has a name, but how do we access that name inside the class? Well, we first have to create a new object. This is the first time we're going to be creating an object, and it's as simple as defining basically a data type and a variable. So all we have to do is type in list, and since we've included the list.h file, the compiler will know how to resolve a list as a class, and then we're going to go ahead and specify what we want to call that object. So we can just say, let's call it simple list. Why not? So now we have a simple list object of a list class. So what does a simple list look like? Well, it looks like everything that we've specified here in the header file. So it has a constructor, a deconstructor, which do nothing. Everything's under public. It has a vector called list, and it has a string called name. It has 4 functions, all that don't return anything. And how are those 4 functions defined? All in list.cpp. So we'll go back here. And then, so how do we access name inside of list.h? Well, we do simple list. and then we do a little dot, and now it knows that name exists in simple list because it's a object of class list. So we can also do that with print menu, so simple list dot print menu, and it should resolve. Everything looks good so far. Let's go ahead and save this. Let's try to run it now, make sure that there's no problems. We've done quite a bit of cleanup at this point. So we'll just do the make command, and it looks like everything compiled. Notice that we do have another line added in here because we're actually compiling two objects now, the main CPP file and the list CPP file as an object. So you can see here you have your list CPP, main CPP, and then they're linked together. So let's go ahead and simply run simple list. And first let's do it without an argument just to test it, make sure that it tells us that a username is not supplied. And look at that, username not supplied, exiting the program. Great, so far so good. Let's go ahead and rerun our program, this time with a username. And looks like we got our menu again. Awesome. So let's go ahead and add a couple items to the list. So option 2, I'm going to add item 1. I'm going to add another one, item 2. And I want to print the list, so I'm going to go ahead and hit 1. And look at that, printing list. We have item 1, item 2. Let's go ahead and return to the menu by typing in uppercase M or lowercase m. Now let's just go ahead and quit out of our program with 4. And it looks like everything's working properly, just like it did before. But now we have the knowledge of classes, and let's look at why classes and object-oriented programming is so powerful. As you can tell, the main CPP source file is a lot smaller now, only with the main function. It looks very simple, easy to follow, and you can also recognize that in the list H and CPP file, we've now grouped things that are of a similar function. So it really makes sense to go ahead and put these all together alone by each other and separated from everything else in our program. We have a really nice user-defined class here, and this has really given us some great structure at this point. I hope you enjoyed this video and programming with me today. Make sure to go ahead and look out for the next video in the series coming soon. And if you have any comments, suggestions, or questions, make sure to go ahead and post them in the comments section below. Also, make sure to subscribe and hit the notification bell for more videos in the future. And thanks for watching.